But let's do a bigger network. If you want to run a bigger network, you need to use channels. I haven't talked about channels really at all. We talked about it when we were talking about wireless propagation. But if we're setting up a big wireless network, we're going to need to use channels. So let's just say we have our big building here. I set it up in 3 dimensions, sure. So this building is kind of tall, but it's really narrow. Okay, so I got 2 floors here. And what I want to do is set up access points on each floor, and they'll go in the ceiling, so I'll just draw them like here. And let's put one down here. And I worry a little bit about the blocking. But what I want to do is set them up so I have coverage over the whole building. And what that means is each access point is going to be sending out their things. And I can do this, well, let's just do that. So what I need to do is set channels. I don't know why I don't care about that. It's a tall, narrow building. You guys shouldn't be able to recognize that. Okay? So our problem here is we need to avoid adjacent. We need to avoid interference between the access points and between the clients on the various access points. So we need to have adjacent access points to use different channels. In the 2.4 gigahertz range, there's only 1, 6, and 11. Those are the only channels that don't overlap, that won't interfere with each other. There are some people that will push it, and you can use like 1, 4, either 7 or 8 and 11, and those kind of don't overlap. But these 3 don't overlap at all, so they won't interfere with each other at all. And this is what most people use. So if I go over here and I say this one is going to be channel 1. Oops, I'll just draw number 1. I can't do 1s very well. So this one is channel 1. That looks really terrible. Sorry. That means this needs to be channel 6 or 11, because it can't be 1, because if it's 1 then they'll interfere with each other. So I'm going to go with 6 here, and that means again, you know, these are on that and they won't interfere with each other. Okay? When I get to my next one over here, I basically have a choice. You know, I used 1 here. I could probably go 1, but I think I'll go, I don't know, it doesn't really matter. What should we put? Should we put 1? The problem is there's only 3, so that means I'm going to have to do 11 here. And let's do 6 here and 11 here. And you can see that I might have a problem with some interference. For example, if a station is like right here. Oops, that's not a station. Lovely. Okay. Because they might have interference between these guys, and then their signals go out. What a mess. What a mess, what a mess. Okay. So I'm kind of pushing it to the limit, and either way, I guess the bottom line here, it's as much as an art and a science. Okay, you want things to not overlap. This is like me trying to choose a channel relative to my neighbors. And when I flip up my access point, let's say I'm here, I got a neighbor next door and on the other side of me, and I got neighbors on the back doors, and then I got neighbors across the street. And what I'm trying to do is pick sort of the least worst or the best of the worst interference patterns. And so whoever I hear the strongest, so if I hear a channel 1 really strong and a channel 6 really strong, that means I'm going to pick channel 11. But really, as everyone gets stronger and stronger, you know, I kind of get squeezed in here. That's kind of scary. So wireless is bad. At the 5 gigahertz range, there's a lot more free. The problem with that, and it's actually kind of an advantage, more and more of the bigger companies are moving to that because you have a lot more channels here, so I have a lot more to choose from here. And they also don't propagate as far. That means I have to put more access points out, though. That's why businesses don't like it. So 2.4 gigahertz, I put the stations far apart. There's not very many channels. It's like the golden zone problem, right? 5 gigahertz, I got to put more channels in and put them closer together. So that's fun. This is all fun, 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 fun. All right, so last comment on bigger networks. This is actually pretty much it for wireless Ethernet. We need to consider our layout and the blocking properties of your walls. Okay, so if I look here, I have to understand, here's my floor of this building, and it has these sort of blocking characteristics too. So I need to understand, how much it's going to block various signals. That's the science part is you walk around with a signal detector and see how strong the signal is. So we got to consider the layout of the walls and the blocking properties of them. If we're going in 3 dimensions, that's going to be more complex. So this is fun. I drew this as a tall building, right? Tall and narrow. Most buildings are kind of squatty, and so I'd have a whole set of access points. Can't even see that in 3 dimensions, sorry. Like up above the paper. And so now I have to pick, here's my access point right here. And the tent above, right? What channel am I going to put that on? Probably 11. And if I go over here, if I do that 11, I'm going to have to do that 1. That means over here, I'm going to have to do 6. You got to do the same thing in 3 dimensions. It's not a fun experiment. These poor ODU guys, every building at ODU has complete wireless coverage. And so they're dealing with this stuff all over the place. And you got to know where you're mounting them on the ceilings and everywhere else. Okay? So 3-dimensional. You might also see where you can do something called a wireless range extender. These actually add another device. So I don't want you guys to be tempted by this. If I have an access point, and let's say I picked channel 1, if I have a range extender, that's just another access point. It's going to be on channel 1 too. As it gets signals from the access point, the range extender is going to send them out also. What that means, though, the range extender has to wait until the access point is finished, and then it broadcasts the signal out. That means everyone else has to wait again. So you basically halved your possible throughput. I don't recommend it. The advantage of this, though, is people can move around seamlessly. Like you can just walk around and you don't worry about it. And some people, in your house, it's not a big deal. You half your throughput automatically. It's just automatically. But some people don't want to do it. If I was on 802.11n, I'm not going to saturate my internet connection with this. So I might do it. I talk about how bad my house is, right? I could put a range extender on the first floor, and then I could use my 5 gigahertz network on the second floor. But it makes a little more sense if I could just run a cable. This is only if you can't run a cable. Because in my house, I could just draw a cable, and then I could have 2 separate access points on 2 different channels, and then I don't have this problem. So a range extender is a wireless way to extend your network. But again, it cuts your throughput in half.